if it's right.
Okay.
So let me do that here. Okay, so
Okay.
square root of,
So yeah, I had that, and on top of the V, there was a little 3 right there.
okay,
And then 216 below the line.
like those 216
Yes.
and nothing more.
No. It
Okay,
said a cube roots.
great. Okay, so let me actually, let me grab something real quick from my website. I've got a cube roots reference sheet that's going to be really handy here for us to look at. So let me first get the link to that. So this is just one of those that you need to know. Now we're gonna talk about how to do this, but so I'm gonna send you the link. So this is a reference sheet that's all the cube roots you'll ever need to know for this, and then let me go get that list there. Just a moment here. All right, so there it is. So what I did is I came up with a list that I think most students ought to know, especially for standardized testing like you're looking at here. And there's actually a small bit of difference between this and square roots we'll get into, but on the right, you can see the cube roots. On the left, these are the cubes. And so these are just ones that you want to know. And the way it works is, for example, the one you provided, 6 cubed is 6 times 6 times 6, which is 216. And so generally you would just say, oh yeah, it's 216, or it's just 6, and you would just know that answer. But to actually do it requires a bit more understanding. So let's take a look at that. So the cube root of 216, you actually build a factor tree the way we've done with other problems. So you start with the smallest prime number, which is 2. And you say, okay, does 2 go into 216? And the answer is yes. 2 times 108. And then you try 2 again, 2 and 54. And then you try 2 again. Okay. And then you say, oh, well, 2 doesn't go into 27. But what is the next prime number that you should try? It's 3. So you try 3. You say, okay, well, 3 works, 3 and 9, 3 and 3. Now this number, and you said on top of the V, that this thing is actually just referred to as the cube root, or the root symbol. This is the root symbol.
Yeah.
And there's more than just the cube roots. There's 4th roots, there's 5th roots, there's any number of roots, infinite number of roots. But you're looking for, go ahead.
I'm confused with every like arrow there is, and it's like just below a number. Why is it connected to that number?
So 2 times 108 gets you back to 216.
Yeah.
2 times 54 gets you back to 108. 2 times 27 gets you back to 54. So what you do is you divide this 216 by 2 to get 108.
Yeah.
And you start with prime numbers. It's called a prime factorization. And so all the numbers on, and if you believe that this is a tree, these are the leaves out here at the edge of the branches. The leaves should all be prime numbers when you're done.
Yeah. What are the prime numbers again?
So prime numbers are only divisible by 1 and itself. So
Okay.
for example, 4 is not prime. Sometimes it's easier to talk about what is not prime because it's divisible by 1 and 4, 2 and 2. And then those are what makes it, that's what makes it not prime, the fact that 2 goes into it.
What about 7?
7 is also prime.
Okay.
11 is prime, 13 is prime, 17 is prime, 19, and so on. And you can go to the internet, but you generally don't ever need to get up this high. You just need to know the first few. 1 is not prime. That's sometimes a question you get asked on exams, true false kind of thing. So because you're looking for a cube root here, you're looking for triples. You're looking for 3 numbers. See how there's 3 numbers there, 3 2s, and there are
Yeah.
3 3s here. So for each triple, you can bring one out. So you can bring out a 2 out of the root. You can bring a 3 out of the root. So the cube root of 216, as I mentioned, you bring a 2 out and a 3 out, and there's nothing left over. So it's just assumed to be 1, and that's why it's 6.
Because you can, because 6 times 6 is 216.
Yes, yes. But so like I think the perfect cubes and cube roots are good to kind of start with, but I think the questions you're going to really be asked are something more like the following. Let's say I asked you for the cube root of 16. Okay, and if you look at that reference sheet I sent you, you'll notice that it is not on there. There's no perfect cube root of 16.
Yeah.
Okay, so we build this factor tree again. You start with the first prime number 2. 2 times 8 gets you back to 16. Do you see that?
Mm-hmm.
And then 8, 2 times 4. And then 4 is 2 times 2. Now, because it's a cube root, we're looking for a triple. So you want to circle a triple of 3 numbers that are the same. That means you,
That's 3.
yes, because of that 3. That 3 tells you how many numbers you're looking for that are the same. So that means you can bring a 2 out, but this one is left over. So that means the cube root of 16, you bring a 2 out, but what's left over? That 2. So see how that 2 has to stay inside?
Yeah.
Okay, let's try another one here. Let's go with the cube root of 24.
Wait, but how do you finish the formula? Like, do you get to
This is
0?
done. This is done.
But how?
Well,
Do you
because
skip it?
we have prime numbers on the leaves. See how all the edges are prime numbers?
Yeah.
That's how we know we're done. So you'll see that in this problem. Okay, so let's start with the smallest prime number, 2. 2 times 12 gets you to 24. 2 times 6 gets you to 12. 2 times 3 gets you to 6. Now, do you agree that all these numbers on the leaves are prime numbers?
Yes.
So you stop, you say you're done. So if you're building a recipe, the first step is to do this prime factorization, or building a factor tree. It's really what I call it. And then the second thing is you look for, in this case, you're looking for triplets because of that 3. That 3 tells you what you're looking for. So here's the triplet there.
Yes.
So for each triplet, you bring the number out. So that means we're bringing a 2 out. We're going to bring it outside the cube. The 3, though, there's only one of them, so we can't bring it out.
Okay, so are you trying to get like closest you can to 0 with that actually going to 0, and then you stop?
You stop when you get all the prime numbers, and like the wording you're using, maybe I don't want to say you're wrong, because it like what you said is true. But we generally don't refer to that here. Like you're using words that are, maybe they make sense to you and keep going with them, but like you wouldn't want to talk to another math student that way. So it's okay for your own understanding if you want to do that, but you stop when you get to this factored form, prime factorization here.
So if the little number was 4, then you would have to go to 4 prime numbers and then stop.
Yeah, let's do at least one more here, because I think I'm gradually getting to where I think you'll see this. So let's go 72 here. Yeah. Okay, so again, you're gonna break this apart. 2 and 36, 2 and 18, 2 and 9, 3 and 3. So do you, again, like, this is very important. Do you see that on the leaves, there are
Yeah.
only prime numbers?
Yeah.
So for each triple, in this case, because it's a 3 there, you're going to pull a 2 out.
Okay.
Okay. But here, there's not a triple. There's just 2 of them.
So what do
So
you do?
you leave them on the inside. So it becomes 2 because it comes out cube root of 3 times 3. These come here.
Okay. That's I'm still like a little confused, but could we will I learn this next year?
Not sure. Probably. I mean, it's
Matthew?
yes. I mean, I think you will.
Okay.
I'm not sure. It depends on the instructor. I mean, you should get this at some point. For now, what you really want to do is you want to focus on this list right here. Like, you want to know this as well as you know your multiplication table.
Could you did you put that in the chat or
I did. Yeah, I already sent you a chat link to that. So
thanks.
I'll try to remember to put it in there, but all this stuff is on my website, so you can always go there and find it if you need.
Okay.
Okay, so let's look at the let's do our practice here for standardized testing. Let me actually have you work on this week's question of the week. What I wanted to ask you before I put it up here is, do you want to give the question a try, or do you want me to show you the skill that you need to be able to do this problem?
I want to try it first.
You want to try it first? Okay, very good. All right, so let me snip this in. So I want you to take 3 minutes here and see if you can work on this on your own. So I'll check in with you at minute 26 here.
Okay. Cool. 10 years.
Okay, so you come up with the
B,
answer
10
of
years.
10 years. Yeah. How confident are you in your answer?
Matthew.
Yes. How confident are you in your answer?
Pretty confident.
Okay. So let me work through this problem with you just to kind of show you what kind of steps would be needed. The person here is starting 2 crops, and the first crop, they have what's called a fixed cost, which means that they have to have that before they even start, and then $500 or 500 per year. The second crop has a different startup cost, which is 500, but this time it's 2,000 per year. And since they want to operate both crops, we have to add these together here, 2,500 plus 2,500x. And they have $27,500 to do so. So when you subtract the 2,500 from both sides, you get 2,500x equals 25,000. Divide by 2,500 and you get x equals 10 years.
Oh, nice.
So this is the first question where you've been able to do it on your own, first time. And I think that's a really great milestone because, you know, these questions are generally going to be more difficult than what you're going to see in, you know, in your standardized testing. So I think that's great. I mean, it's definitely something that we should be, you know, pleased about. So let me give you another question, and let's see if you can do it faster, because speed is really important in these standardized tests. Not necessarily, you know, for real life, but you know, in these tests, that's definitely a consideration. So
I think I might try to get a thing that lets me do like extra time on tests, because whenever I do a test on school, no matter what subject it is, I'm always the last one to finish. And it's not just because like I take my time, I'm always like just getting to the last question.
sure, yeah, I mean, I understand that. You still, you know, this is going to be an important thing to think about. So go ahead and see how fast you can get this done. Let me know when you get your final answer, and we'll talk about it when you're finished.
Okay. I have a question.
Sure.
Is a fixed cost only one time or
Yeah.
annual?
Yes, fixed cost as well as startup cost are the one time.
Nine years, I think.
Your answer is 9 years.
Yeah.
Okay, how confident are you in your answer?
I'm pretty confident because can I just tell you what I put?
Sure.
So I put CA for like California,
Uh-huh.
and then minus 4,000 and then minus 8,000 per year. And then, because like you're paying it, it's like the money is going away.
Okay,
And then I put NY for New York. And I put minus 5,000, and then I put minus 1,000 per year.
Okay.
And then I did 4,000 plus, or negative 4,000 plus negative 5,000 is negative 9,000. So it went from him having $90,000 to $81,000.
right,
And then it was the $88,000 per year cost plus $1,000 per year cost to
yes,
get $9,000 per year cost. So with $81,000, 81 divided by 9 is 9.
excellent. Okay, so your time on that was 1:45. Let's do one more where the goal here is to do it as fast as possible. Okay, so
It was right.
yes, yes. So let me grab, this will probably be the last question we do on the question of the week. We'll move on to some other stuff because you got it down so well. But yeah, let me snip this in. Are you ready?
Yes.
All right, here we go.
Hi. Okay. I think I got it.
Okay,
So
what is your, you want to tell me what you did?
yeah. But so I know I got, if I got it wrong, I know I got it really close. But for Montana, minus 2,500 and then minus 10,000 per year. So maybe just PY.
Okay,
And then Ohio minus 5,000. And then minus 5,000 per year.
okay,
And so for not the yearly ones, just for the one-time cost is 7,500 combined.
okay,
He has $52,000, 500. So 52,000 500 minus 7,500, 45,000, and then 15,000 is the cost per year. So 45 divided by 15 is 3. I think 3 is it.
perfect. Well done.
Nice.
All right, so let's go back now. And let's talk about square roots instead of cube roots for the moment.
Okay.
So the square roots, like let's say I ask you for the square root of 12. This is the same as the cube roots in the sense that you have to build a factor tree.
Isn't the square root or something like a number multiplied by itself Which gets you to the answer.
Those are perfect square roots, and they are not the most common ones.
Okay.
So this is why you got to build this factor tree. So if 2 goes here, what number goes here to the right?
6.
I'm sorry,
6.
6. And then we try 2 again, what number goes here?
3.
So notice these are all prime numbers. Now, what is not written but assumed, is that there's a 2 there. So now we're looking for pairs. Do you see that?
Yeah.
So for each pair this time, for each pair, you bring 1 out.
So you take a 2 out.
You bring a 2 out, and what's left inside?
3.
3. So the way you write your answer is it's 2 square root of 3. So the square root of 12 is equal to this. These are the same, but the one on the right is simplified.
Okay.
So let's try another one here. Let's try the square root of 27. Does 2 go into 27?
No.
So we go to the next prime number, which is
3. Yes, it goes into 9.
yeah, 3 and 9.
3.
3 and so for each pair, you pull 1 out.
What about for each triplet?
We're not doing a cube root. We're doing a square root.
But a square has 4 sides, not 2.
Yeah, it's square refers to the exponent.
Okay.
And yeah, right. The square has 4 sides, but many other shapes also have 4 sides. So we don't want to just go with that. So this time you bring a 3 out, square root of 3.
Mm,
Okay, so let me have you try one on your own here. I'm not going to make it that much more difficult than the ones we've been doing. Just it's the same.
Wait, but why did you put 3 in the answer twice? Can you tell me where each 3 came from?
You pull 1 3 out. That's why I keep showing you this arrow here, because that means it's coming out.
Yeah.
That's this one. The one that's left over stays inside.
Oh, okay. Okay.
So this one is really similar. It's going to have a number on the outside, a number on the inside. So go ahead and give that a try, please.
Yeah. Three on the outside and 5 on the inside.
That is correct. 3 square root of 5. Good. Okay, so let me have you try another one here.
Okay. Good. All right, so 5 on the outside and 3 on the inside.
That's right. Perfect. Okay. So let's try one that's a little bit more difficult here. Let's
Okay.
go with the square root of 24. So give this a try. I'll jump in and help if you have questions, but I do think you can do this. So take about a minute and see if you got it.
Got it.
If not, we'll
Okay. All right, so 2 on the outside and 3 on the inside.
so let's build a factor tree here. 2 and 12,
12, yeah.
2 and
6,
2 and
3.
so we can only bring out a pair. So the twos one of the twos comes out. Do you agree with that? What is left over?
2 and 3.
2 and 3. So they go down here
2.3.
at times that you're multiplying. So it's 2 square root of 6.
What? How about instead of doing 2 times 3, you can just still go, oh, what's the 2 we took out? Okay, what's the number next to it? 6. And then that'll be it.
That sometimes works, but you know, you want to be careful here. There will be some exceptions to that. So let's try one more here. This will probably be our last question for today. Square root of 60. Why don't you give that a try, please? And I definitely recommend you build your factor tree.
Okay. Okay. Outside 2, inside 15. Wait, no. Well, actually, yeah, I think that's right.
Yeah, so 2 doesn't work, so you go to 3 and 5. And so one of the reasons you don't want to do what you just said is that in higher levels of math, you may actually write the number like this as truly its prime factors. Now, what you said is correct. It is 2 square root 15, but you know, we want to do it the right way.
Okay.
So good. Okay, well, that does take us to the end of our lesson for today. Your mom had mentioned scheduling some stuff for next week, so I look forward to helping you then. And I'll send you the notes and the screen recording here shortly.
Okay, thank you, Matthew.
You're welcome. Bye now.
Bye.